Let's take a look at the angle relationships in polygons. First of all, a polygon is any shape with 3 or more sides. Okay, let's look at the exterior angles. First of all, exterior angles are just created by extending all of the sides in one direction. So, extend this side, something like this. Possibly extend this one this way. It doesn't matter which way you extend them at each vertex. So this one could be extended this way, for example, or we can extend it this way. It doesn't matter. Let's just extend it this way, though. Then we'll do the same for this one. Let's extend this one this way, and we'll just extend this one this way. So we have 1, 2, 3, 4, 5 exterior angles, and of course we have 1, 2, 3, 4, 5, 6 exterior angles, and we have 6 sides. So the number of exterior angles always equals the number of sides. So let's say this is A degrees, B degrees, C degrees, D degrees, E degrees, and this will be F degrees. Okay, the sum of these, if we add it up, is always going to equal the same thing. It's always going to equal 360. So the sum of the exterior angles is always 360, and that's true for any polygon. So for triangles, squares, trapezoids, hexagons like we have in this case, pentagons, octagons, doesn't matter. The exterior angles always add up to 360. Interior angles, though, the sum of the interior angles will be different depending on how many sides there are. So for a triangle, we know a triangle has 3 sides. The sum of the interior angles is 180. A quadrilateral, such as a square or a parallelogram, has 4 sides. They add up to 360. A 5-sided figure, a pentagon, the sum of the angles is 540. And a hexagon, a 6-sided figure, the sum of the interior angles is 720. Okay, so you should notice that every time we add a side, the sum of the angles goes up by 180. So if you need to know how many or what the sum of the interior angles of a certain polygon is, just make a quick chart, start with the triangles 180, and just keep on adding 180 as we increase the sides. But there is a formula for this. S, which is the sum of the interior angles, is just n minus 2 times 180. So S is the sum of the interior angles, n is the number of sides. So if we had a 5-sided figure, we'd have S equals 5 minus 2 times 180. So we'd have S equals 3 times 180. And we'd find that the sum is 540, just like we had from our chart. So this is the formula for finding the sum of the interior angles. This is a chart version. And then, of course, the sum of the exterior angles for any polygon always adds up to 360. Something else we should go over is a regular polygon. Regular means all sides are congruent. So they're all the same length, and also all angles are congruent. So if we had a regular pentagon, so this has 5 sides, it's a 5-sided polygon. We know what the sum of the interior angles is going to be. We can simply find the sum using the formula S equals n minus 2 times 180. So S is 5 minus 2 is 3 times 180. And we know the sum is 540. But because it's a regular pentagon, all the interior angles are the same. So a pentagon looks something like this. Obviously this is not a regular pentagon. This is just a sketch. So all the sides aren't exactly the same and all the angles aren't the same. But being that they're supposed to all equal the same number, we could find out how big each of these angles will be. We just simply divide the 540 evenly among the 5 angles. So we get that each interior angle is 108 degrees. So each interior angle is 108 degrees. So this angle is 108. We can find an exterior angle. This whole thing has to be 360. So this has to be 72 degrees. Another way to do it is to know that all the exterior angles of any polygon has to add up to 360. So if they all have to be 360 and there are 5 of them, just do 5 divided by 360. When we divide that, we get 72. So 72 is the exterior angle. Each exterior angle is 72 degrees. So I have a 72 here, 72, 72, 72. And because each exterior angle is 72, and this has to be 180, we could find that each interior angle is 108.